Okay, so listen. A ball is projected horizontally from the top of a building. State the factors on which the distance at which it strikes the ground from the foot of the building depends. Let's understand the question. We are to state the factors on which the distance at which it strikes the ground from the foot of the building depends. What is this distance? What is this distance in question? The distance from which it strikes the ground from the foot of the, what's that? What is it called?
The range.
The range. Okay. So if you are not able to decode that this distance from the foot of the building thing is the range, you will not understand it. Okay. So, but this is about a horizontal projection, because the question says a ball is projected horizontally from the top of a tall building. So it's like having a structure like this, and then a ball projected from the top of it. Okay. So from the foot of the building to where the ball hits the ground is the range. And the question demands that we state the factors. Okay, state the factors on which the distance at which it strikes the ground depends on. What is the first factor on which the range depends on? Yes. Yes. Akuya, who took over my hosting right?
Time of flight.
I would, yes, you are not wrong, but rather I want you to talk about the time. It depends on the time. Is that okay? Depends on
Yes.
the time. Two. So one time. Two. What's the third factor on which the range depends? Yes, feel free. Feel free and express your view. Oh, who is talking?
The velocity of projection.
The velocity of projection. Good. So velocity of projection. Three. Yes. 3. Lizzie, Len, Nanama, Leon, Lauren, speak. I'm waiting for you. And then the height of the building. This is a reason. You see, for a horizontal projection, the range is equal to U times the time of flight, or the time T. But this vertical height H is also equal to half J T squared. What it means is that H is directly proportional to the square of the time of flight. So if time of flight depends on, or if the range depends on the time of flight, then certainly the range would also depend on the height, because T here and T here are the same. All right, so H, the height of the building, also affects the range. Then Another important factor on which the range will depend is this. Every moving object or every moving body has what we call momentum. Okay, every moving body has a momentum, and momentum is a measure of the motion of a body, a moving body, the extent of movement of a moving body. So momentum, that's the next topic. We'll look at collision, momentum, and then collision. Momentum is equal to mass times velocity. So long as the body has a mass and it's in motion, then it means it has momentum. So every moving body has momentum. Okay. If the range depends on velocity, because the body moves with a certain velocity, then it means it has momentum. So once the range depends on velocity, then it means the range would also depend on the mass of the body being projected from the top of the building. But under projectile motion, you learned about velocity of projection and time of flight and then height. But an unknown factor which I am bringing in is the mass. Okay, imagine you are here throwing this object. If let me put the question to you. If the body is if the mass is large, can you be able to throw it to drop at a far point? Class?
No, please.
Yes.
No,
Imagine
please.
you are here and I give you a ball, small ball to throw. And then I give you a bigger ball or a stone to also throw from the same height. Which of these two would give you a larger range or will produce a larger range? Will it be the smaller mass or the bigger mass? You haven't answered it all. The smaller mass will give you a larger, so the range also depends on the mass. All right. If you have any question, quickly ask before we continue. All right. Then let's look at this question. Oh, I think we jumped. Let me see. Okay. Yes, this question on projectile motion properly. And listen, a projectile is launched from ground level to the top of a cliff, which is 195 meters away and 155 meters high. If the projectile lands on top of the cliff 7.6 seconds after it is fired, find the initial velocity of the projectile, magnitude and direction. Neglect air resistance. How many of you attempted this question? Question 2B. Lizzie attempted it. Who else? Okay. It isn't a difficult question. It isn't a difficult question at all. So please fasten your seatbelts. Cruise with me whilst we go through, we dissect the question. So a projectile is fired on the ground. There's a ground level. It is fired here. Now, it lands on top of a building. So this is the building. From the point of projection, to the building, we are told the range is 195 meters. The height of the building is 155. So the building is 155 meters high. Then it is projected and lands on the building. So let's draw something to represent the trajectory. So this body goes, it is shot at an angle, gets to the maximum height and lands on the building. The angle of projection, we don't know. Theta. The velocity of projection, we don't know. From this point to where we are identifying as the maximum height, so this whole vertical height is H max. Okay, now we don't know the distance the body moved from the maximum height so where it lands on the building. So let's represent this distance from the maximum height to the top of the building by the letter S. We are given the total, the time of flight, and the time of flight is the total time taken during the whole journey of the body. But from what we have, we could deduce something that the time of flight would be equal to the time taken for the body to move from here and get to the maximum height, which we can determine using U sine theta on G plus the time taken to move from this point, the maximum height, to this, which we don't know, but let's represent that by T subscript S. S because we are representing this distance from the maximum height to the top of the roof or the tower by S. Please, are you with me? Are you with me?
Yes.
So the time of flight is the time taken to reach the maximum height plus the time taken to move from the maximum height to the top of the tower. So that's what we have, but we know the time of flight. All right. Now, how do I determine this? If I could find this distance H, I can easily determine TS. Okay. Now, so we are interested in determining the relation for S. That's S. Now, when the body is moving from the maximum height, it is free falling. And when it is free falling, what does it mean? If the body is in free fall, what does it mean?
It has velocity.
Come again. If the body is free falling, what does it mean?
His initial velocity is 0.
Good. So the body's initial velocity at the maximum height is equal to 0. So if this U is equal to 0, then using S is equal to UT plus half JT squared. We can find this distance S because U is equal to 0. So this part would go off. So S is equal to half JT squared. Therefore, the moment we make T the subject, so T squared is equal to 2S over G. T therefore is equal to the square root of 2S on G. And this gives us the time taken to move from the maximum height to the top of the tower. Okay, So when we substitute that into the formula, time of flight formula, we have time of flight is equal to the time taken to get to the maximum height plus the time taken to move from the maximum height to the top of the roof, which is square root of 2s on j. Watch and ask question if you have any. If you have any, ask so I can explain, so we could move on. Now, look at the maximum height. The maximum height h can be related to this distance s plus the height of the tower, which is 155. And so let's make s the subject. Let's make s the subject from this relation. S is equal to, yes.
H minus 155.
So S is equal to H minus 155. And we have a standard formula for H, isn't it? We have a standard formula for H, isn't it?
Yes.
Yes, on. What's the standard formula for maximum height? H max.
U squared over 2g.
So U sine, please, it's a shot at an angle. It isn't a vertical. U sine theta squared over 2g. Are you okay? So when you substitute this into this relation, you have a formula, an expression for S. So S is equal to U sine theta squared over 2g minus 155. So if you have this relation, substitute it into the time of flight formula. T therefore is equal to U sine theta over g plus square root of 2 times S. And what is S? S is the whole of this. Okay, so 2 times U sine theta. Okay, you can square it. U sine theta, sine square theta. Okay. Over 2g minus 155. Don't forget, the whole of S is what is within the brackets. Okay, divided by g. So let's divide 2 by g. But S is what we put inside the bracket. Please, are we okay? Are we fine? Okay, so let's take our time. In fact, it looks something, but please, let's take our time and then solve it. You realize that this is nothing so difficult. Okay, let's handle what we have within the bracket, simplify. Then we multiply it with what is outside the bracket. That's how we solve a problem, okay? You don't put the two together. So when you, let's simplify what's within the square bracket. Okay, LCM is 2g. The LCM is 2g. So we have T, let me be sure if you can see. T is equal to u sine theta over j plus square root 2 over j. We haven't touched it. We are only simplifying what we have here. When you cross multiply, you have u squared sine squared theta minus 155 times 2j over 2j. Please, are you clear with what we have here? Are you clear with what we have there?
No.
We are only handling what is within the square bracket, simplifying it. So I multiply this by this by that. Then divide by this times this. Okay, so 1 times this is the same value. 2j times 155, I have 155 times 2j, all divided by this times this, 2j. Okay, I haven't done anything new. I'm only simplifying what is within the brackets. Okay, therefore, t is equal to u sine theta over j plus. Now, j has a value. In the question, we're giving j to be 10. So it means this is root of 1 on 5 because j is 10. Let me take my time, put it there. 2 divided by 10 into brackets u squared sine squared theta minus, since j is 10, okay, substitute j, multiply it by 155 by 2, and then give me the final result. So 155 by 2 times 10, or 155 times 20. Lizzie, what did you get? 155 times 20.
$3,100.
31.
It's 3,100.
All divided by 20. Because 2 times, I've substituted the value of j, which is 10. Okay.
Yes.
So please, are you following? Are you following?
Yes.
We are simplifying it bit by bit. Okay. So t can also be, we are looking for u, we don't know. But j is 10. Don't forget, we are also giving the value of the time of flight, 7.6. T is equal to 7.6. 7.6. So 7.6 is equal to u sine theta over 10 plus square root of, this is 1 over 5. Okay. 1 over 5. Even times u squared sine squared theta minus 3,100, all divided by 20. I want to adjust the screen. So if you are writing, quickly do so I can move the screen. It's now becoming clearer. It's becoming clear. So can I move the screen?
Yeah.
All right. Okay, so 7.6 is equal to u sine theta on 10. Now look at what we have. Multiply numerator by numerator, then denominator by denominator. So plus the root of u squared sine squared theta minus 3,100 all divided by this time this is 100. Okay, all divided by 100. So u sine theta over 10 plus the square root of, you see, when you have irrational expressions, take the square root of the numerator, take the square root of the denominator. When you take this one, we cannot simplify it, so it will still be u squared sine squared theta. I'm coming. Let me clear this part a bit and then. So we have root of u squared sine squared theta, so minus 3,100, but divided by, when we take the square root of 100, you have 10. You have 10. Becoming clearer. What I can do is that I can eliminate the denominator 10. I can eliminate the denominator 10 by multiplying through by 10. So I multiply through each term by 10. 7.6 times 10 will give me 76. This multiplied by 10 would eliminate the 10. This multiplied by 10 would eliminate the denominator. So we have this. U sine theta all squared minus 3,100. Please, are we okay up to this point? Up to the last stage?
Yes.
Okay. So all that we are trying to do is to eliminate the square so that we can add u sine theta. So we square both sides of the expression. So I square the left-hand side and then square the right-hand side. What is 76 squared? What is 76 squared? Quick one, 57.
57.76.
57.
0.76.
Okay. So 5776 is equal to, when you square what we have here, you have to be very careful because we have A is like, this is one term A plus, this is another term B. So if you have this and then you are squaring, okay, please pay attention. If you have something like this and you are squaring, this term squared, A squared plus the square of B, then the product of this and this is AB multiplied by 2, so plus 2AB. So you have to be very careful. So this is one term. So u sine, hello.
And please, what about the 10? I think, wouldn't you divide through by the 10?
We multiplied through by 10 and eliminated it. That's how come 7.6 changed to 76. So at this stage, we multiply through by 10 to eliminate it, the fraction.
Okay.
Are you okay? Are you okay?
Yes.
All right. So a square of this, then a square of this. A square of this would eliminate the square root sign. So we have plus u sine, let me, the marker. I'm coming in. I hope I can clean this side. So we can continue from here. Of course, the video would also be sent. So So Lizzie, what you have to do is that you have to indicate that at that stage we multiply through by 10 to eliminate the fraction, okay? I don't usually write
Yes.
everything, so good. So when you square this, you eliminate the square root sign. So you have u sine theta squared minus 3100 plus, I said a squared in expanding something like this, a squared plus b squared plus 2 times ab. So we have to multiply 2 by all that we have within the bracket. So plus, there's the continuation, plus 2 u sine theta times the square root of u sine theta squared minus 3100. Please, when you see something like this, do not be scared. It's the same mathematics. Okay. Now, once we've succeeded in eliminating the square root sign, we can now group like terms. Okay. We can group like terms easily. You can send minus 3,100 to add to 5,776. So we have 5,776 plus 3,100. And that is, I've signed this to this side. Then we have u sine theta squared plus another u sine theta squared, which is equal to 2 u sine theta all squared plus this lengthy I want to adjust plus 2 u sine theta times I'm coming. So this squared, okay, times that. Okay, so u sine theta squared minus 3,100. Okay. So that's okay, let's add this and this. Add 5,700 and that for me. 5,776 plus 3,100.
887.
This is 88.
Seven, six.
Okay, 8876. Okay, is equal to 2 u sine theta all squared plus 2 u sine theta times u. I think we have omitted something. Because over here I think we have omitted something. Okay. I'll check what we have omitted because we have just 5 minutes to close. Okay. I'll check what we have omitted and then perhaps give you the missing link so we complete this one. Okay. Because we have just 5 minutes to end it. So I'll check and then post it this evening on your platform, okay, so that it doesn't take our time. Now, the next question, so I'll complete this evening for you, okay, because of our time. The next question is an inclined plane question. As for inclined plane, I doubt if you had that challenge, because for an inclined plane, this is rolling down the plane, okay, the angle of tilt is 15. The length of the plane is 20. Okay. For an inclined plane, all that you need to understand is that the acceleration of the body down the plane, A, is given by J sine theta. So if you are looking for V, which is U plus JT, okay, when it is rolling down the plane, U is 0. Because U is equal to 0, sorry, A, the acceleration A, when you substitute this, you have J sine theta times T. So whenever you are looking for the velocity within a given time, this is what you use, okay? For the first question, what is its velocity 5 seconds after it was left to fall? Okay, so velocity 5 seconds after it was left to fall, when J is 10, J is 10 times sine of theta is 15 times 5 seconds, and you can find the velocity 5 seconds after it was left to fall. Then what is its velocity of impact just before it hits the ground? Using V squared is equal to U squared plus 2JS. And J must be A, because the body accelerates not by gravity, but by this expression. So U squared plus 2J sine theta times S. U is 0. If U is 0, then V squared will be 2 times 10 times sine of 15 times the whole length of the plane, which is 20. Therefore, V will be equal to the square root of all this, 20 by 20 by sine of 15. That would give you the velocity just before it hits the ground. The reason is that when it hits the ground, the velocity is 0. Now, okay, we have 2 minutes, so let's quickly wrap up. List 3 examples of vectors. As for this, we don't need to talk about it, because to list examples of vectors, it's simple. Okay, 3 examples of vector quantities. Yes, Adwa Tubia, 1. The first example is what? Quick one. Class, let's go through this quickly. Examples of vector quantities.
Velocity.
Velocity, next. Somebody else.
Force.
Velocity. Force,
Displacement.
Displacement.
Momentum.
Momentum. Moment. Weight. Acceleration. Impulse. We have a lot of them. Lizzie, state the parallelogram law of vectors. The parallelogram law of vector addition. That's the last question. Parallelogram law of vector addition. Oh, how do we use a parallelogram law to find for resultant vector?
Okay. By resolving the vectors.
So if two vectors act at a
Wait.
common point,
uh,
at an inclined, at an angle of tilt, or when they are inclined to one another, you resolve them, okay, into a parallelogram, and the resultant is always equal to the is equal to the what? Diagonal. So by determining, after resolving it into a parallelogram, the resultant is always along the diagonal. Okay, and as this is it, and we determine that using our revered cosine rule. Okay, then I'll give question 3B. Question 3B is a scale drawing, and I want you to try and then go through it. Okay, two forces 50 Newton and 70 act at right angles to each other. This one, they are acting perpendicularly, so it's simpler. Act at right angles to each other. Determined by scale drawing the magnitude and direction of the resultant force using a scale of 1 centimeter to 10 Newton. So the forces are 50 and 70. Okay, and they act perpendicularly. You are given a scale that use a scale of 1 centimeter. This is 50. This is 70. So I'll represent this using a scale of 1 centimeter to 10 Newton. So it means this will go for 5 centimeter. And this will go for 7 centimeter. Okay. And here it is a scale drawing. So we expect that you use measurement to find your resultant. So by using equal vector, whatever you had, you measured for the 5 centimeter, measure the same thing for this one, the equal component, so that it will be perpendicular on this. After getting that right, measurement from this point, the tail of this vector to the head of this vector must give you the resultant. Okay, so this is by using a scale drawing to determine it. And I want you to please give it a try, okay, during the weekend. Just use a graph and then take measurements to do that. All right. So our time is up. Our time is up. This is where we end today's show. I think we have another lesson on Monday. Okay. All right. So take care. And this is where I draw the curtains on our meeting. Until same time, I doubt if it's the same time. Another time on Monday, please take care of yourself and bye-bye. I'll check this and then post it on our platform. Okay. All right. Have a nice weekend.
You too.
All right. Okay. Bye-bye.